software that is called SolveSpace, which is really easy to start with software, which has enough features for you to do anything you need during the course, really. And what I like also about it is that it comes with a library. But so here are some examples what you can do with it. There are also some people, I couldn't find this one person. I bumped into it a year ago. There's one person who is taking the Autodesk Fusion 360 challenges. So they have a monthly challenge. So they have a drawing like this, and then people have to record videos about how they make it in Fusion 360, and then whoever does it faster wins the challenge. And there was one person who was trying to do the same challenge, but only with the SolveSpace. So he wanted to prove that anything that you can do with Fusion 360 can be possible with SolveSpace as well. So you can create individual parts. You can create two-dimensional drawings, three-dimensional parts, and assemblies, and I think even simulations with it. So let's say you need a case for your electronics project. That is possible. You can import even 3D representations from electronics design software into it to just validate where your design is going to fit. Here there are tutorials. And it has a nice reference page as well over here. So you can, whenever you have time, read through it and learn a lot from it. So, and today I am going to show you how to design a simple like object, like an assembly object. So you can download SolveSpace here. So there are several ways how you can install it. So here in the GitHub page, you can download a DMG for Mac OS, and you can just download an executable file for two different executable files for Windows. I don't really remember what's the difference about between these. Maybe this is using the OpenMP library and the other one doesn't. So whichever works better for you. So I haven't seen any difference in performance between those two. And then for Linux, you can snap from the Snap store or build it from source. So Ubuntu, it's really easy. You type sudo snap install OpenSCAD, not OpenSCAD, but SolveSpace, and then you can run it. So you type SolveSpace and you open it up. So this is how it looks like. Really easy. So there's a coordinate system over there. So you see there's a x-axis, y-axis. I think the way how you should actually design is by having the z-axis pointing up and the x-axis pointing to the right and y-axis pointing forward. Let's talk about the software in general. So here on the left side, you can see all the tools that are available. So the drawing tools, so you can draw lines, squares, circles, text, curves, and so on. Then here there are the constraints. So geometry constraints, so you can reuse your maths or geometry knowledge. So you were learning about how to make things parallel, that there's an angle in between lines, that something is perpendicular, so all these kind of things. So you can use that all in CAD software. So these constraints are all about that. So you can make something horizontal, vertical, and so on. And then here there are some things that are relevant to making two-dimensional geometry into three-dimensional geometry. Here, there are some things that you can already do with three-dimensional geometry. So like circular, rotating repetition, or linear translating and repetition. And here we can use these tools in order to start sketching on a surface somewhere. And then here we can use this one in order to make assemblies from existing SolveSpace files or step files. And here there are some features that make kind of navigating this view much easier. So yeah. Okay, so how do we start? So we start with just a line. So you have to imagine how you're going to design the thing. So you remember that the chair had sort of it had legs, and the legs looked approximately like this. So I am drawing the line like this for a purpose, because I want to show you how the constraints work. So if you select a line, so you can also continuously clicking, by continuously clicking, you can select multiple elements, not just lines, but also dots like this. But if you select a line and go to constraint and select horizontal, it's going to make it horizontal. So now you can stretch the line, you can move it around, and it's always going to be horizontal. You can do the same with this, but you can make it vertical. And if you select this, for example, so instead of going to the menu, you can also use the shortcut, which is H. So you can just hit H, here H. So yeah, like this. Another thing that we would like to do is, let's say, to make these two lines equal. So I select both of them, I go to constraint and select the equal length. So whenever I change the length of one, the other one is going to be equal. I can make also some helper lines, like construction lines, to make the designing process easier. And I can do that by drawing a line first, like this, and then selecting those lines and going to sketch and toggle construction, or shortcut G. Also, I want to make this vertical and this horizontal, and I want to make this and that line equal, and that's done by shortcut Q. Now it's kind of flying around, and what you can see here in the property browser, for example, there's a number 6, and this number 6 represents the degrees of freedom. So this is like the different ways how you can move the object around, and so there's a purpose, or there's like a motivation or a goal for designing these sketches. So you have to bring this number down to 0. So in the sketch view, you have to do everything possible so that you cannot move any of these elements anymore. So what are we going to do? We can just further constrain it. So I want this to be snapped to the center, for example. So in order to do that, I'm going to go to constraint and on point. So you see now the degrees of freedom were reduced to 4, because this point was, we were able to move along X and also along Y coordinate axes. So now, so the height of it, it's still undefined. So we can select these 2 points and we can constrain and add distance, diameter in between those. So the height of this element is 500 millimeters. So it stretched it a little bit, but no worries. So 500 millimeters or 50 centimeters is kind of a default height of such a chair, such an object or bench, let's say so. Then the radius of the chair, or the size along x-axis here between those 2 points. So the diameter of the chair is of the surface of the bench is 300 millimeters, but half of that. So since we're drawing a half of it right now, so half of it is 150. So we're gonna strain it to 150. And these parts over here, so these were 4 centimeters or 40 millimeters long. So I'm now hit D, and it's going to be 40, like so. And we see that there's 1 degree of freedom still left there. So now I'm hitting shift and middle key. So which is this length. So this is going to be the part where the surface of the bench is going to sit on. And I made it half of this size. So 150 divided by 2 is 75. So let's add 75 over here. And now we see a green OK appeared here, where the latest element is. So you can see that there's sort of, we're building a little history here in this property browser. So First, you got the references, so that's the built-in state of the software, and then we added a sketch in plain, yeah, we can also hide it like this. Sketch in plain, which doesn't have any degrees of freedom anymore, so it's fully constrained, which is perfect, and we can do something with it. By the way, so here there are some toggles that you can show or hide certain elements of the drawing. Then we can use this nearest isometric view feature to project it in 3D. So now it's kind of a three-dimensional sketch, but it's sort of non-existent because it doesn't have any thickness. In order to give it thickness, we need to use this tool. Click it, and you see on the property browser, we have some new properties that have showed up. So one-sided means that it's gonna try to extrude it in one direction. So it's gonna extrude now, towards that direction. But what do we want? We want to make it symmetrical, and this is where we select the two-sided option. So usually in CAD software, you would expect the thickness of the extrusion to be somewhere here. It's a bit different in SolveSpace. So in SolveSpace, you have to select the line. So basically in 3D, you can work in a similar way as you work in 2D. So here, you can reuse the same shortcuts, the same constraints in order to give it thickness. And the thickness of the material that I was using there was 10 millimeters. So sometimes it's a little less, but I'm just going to start with 10 millimeters over here. Now, so since this is only one side of the leg, what we want to do, we want to mirror it. And the easiest way to do this is to select the point and align, and then go to this new group step and repeat rotating part. So you click this, and you see it started repeating the part. This is kind of an interesting design, but this is not exactly what I want. It's not going to be very easy to assemble it afterwards. So what I want to do, I want just to mirror it. And so here in the property browser, so we have some options. So I'm going to go with the one-sided. The two-sided, it doesn't make really much difference in this way. I really haven't read about that option, but so here, instead of repeating it 3 times, we want to repeat it 2 times. I'm going to enter the value, and you see now it's mirrored. It's like a solid object, and we can go back here to the main view home. So I think it's also floating a little bit in the air. Yeah, so the rotation is not really constrained. So one problem that you see here is that when you grab one of those points and you move it around, so it's going to rotate around, so in an unpredictable manner. And over here you can see that we still have 1 degree of freedom left. We want to bring it down to 0. So in order to do that, we are going to make this line and that line perpendicular. So we're going to constrain and perpendicular, and now they're locked in place, and we see an OK here, which means that we brought the amount of degrees of freedom effectively down to 0. So another thing is we want to use some form of finger joints in order to kind of snap fit together with the surface over here. So we're gonna create these finger joints that then are gonna fit into the pockets on the surface of the chair. So in order to do so, we need to create a sketch in plane, and before that, we need to create the plane, to define the plane. And in SolveSpace, the easiest way to do so is to select a point, and then 2 lines that are connected to that point, like this. And then you're going to be able to create a new group in a new work plane over here. Now, in this view, so as you see, you can select all the lines that came before that are underneath this work plane, and we can just draw a rectangle like this. And again, I'm drawing the rectangle in a way, kind of in a free way, to be able to show you some of the constraints. So if you select a point and a line, and then go to constraint, and on point curve plane, so it's going to snap to that line over here, like so. We can do the same with this other point. So point and this constraint on point. Now we can give a dimension. So this is going to be 40. And it's going to be offset 20 millimeters from the center. So constraint distance diameter 20. Now, so we can also see that, yeah, it is fully constrained. That's very good. So we can tune into 3D view and we can use the extrude option. And now, again, we can give a dimension over here and we're going to enter the thickness. Or basically, instead of doing that, if we go a few steps back over here, we can select this, and we can create a equal length radius. So basically, if we enter, so we go back, let's say, to the sketching plane over here. So we can just change it in the history and say, no, so it was, I think, here, yeah. And we have this thickness value over here. So we could change it to, let's say, 15. And then we can go further and we'll see that this size has been also increased to 15. Here. Like so. Yeah, and we can now repeat the same thing with this that we did with the initial part. So we can mirror it. So in order to do that, we have to select a point and a line that we can use for mirroring it, and use this one. And let's change the value to 2. So now we have a solid object like this. And here, the same thing as before. So if we grab one of those points of the extrusions, so it's rotating around like crazy. So we don't want it to end up like this. We want this to align perfectly with the surfaces underneath. So what we can do, we can make, again, this line and one of those other lines perpendicular. So let's try to do that. I'm going to select this line, that line, the constraint, and perpendicular. Now they're perpendicular, and also here in the degrees of freedom column, we see that it's showing okay, which means that we effectively brought down the degrees of freedom to 0. So at this point, it is a good idea to save it. Next is, so we're gonna use this. We're gonna make one version that has a slot from the bottom and one version that has a slot from the. So now I just disabled the possibility to select the faces because it started flickering too much. So I can click on this, and now the faces are unselectable. So I'm gonna create one version that has a slot from the top and one version that has a slot from the bottom. So again, so I need to select a plane where it's gonna happen. So a dot and 2 lines. I'm gonna click this icon over here and draw a rectangle. And here's an interesting trick. So you want this to be symmetrical along this line. So the easiest way to do this is to create a point online. So you create a point wherever, you select this, and then you go to constraint on point. So the line is going to snap to the point or vice versa. And now if you select the point and the line, there's another constraint, which is called at midpoint. So it's going to keep the point always up in the middle. And now we want to snap this point to that point. So you can select both of those and go to the on point constraint. And the next thing is we want to make this to equal the thickness of the material. So we can just select these two and constrain and make them equal. Yeah, like this. And another thing is that we would like to make this to end exactly here in the middle. For that, we're going to use a construction line. I'm going to draw this. Go to sketch, construction, and make this vertical and snap this point here to that line with constraints on point. So now I can still move that, but I can select this line and that line and make them equal. So now they're equal, and I also can see that there's no constraint. Now with this sketch, what I can do is, again, I go to the to a view that represents the 3D-ness of it a little bit more. And I'm going to use the same extrude function here, but I'm going to use some different options here in the property browser. So you see here we have the solid model selected as a union. So it's basically, it combines the existing object with a new extrusion and makes it into one object, but you could also select difference and then it cuts through. And it doesn't have the option of go through all like some other CAD software might have, but you can be a bit smarter. So if I'm going to make this thickness exactly, so this extrusion as deep as the thickness of the material, it's not going to really work. So it has to be a little bit more. And the way how to do it is that you can select, let's say, these 2 points over here, and you could give it a value. Let's say 1 millimeter is just enough. Or you could also make one of those equal something. Let's just enter distance like 10. So and it's going to always cut through, and there's going to be the slot. Let's view it from the front. So basically, this is going to be the bottom of the leg construction. So we can actually go to File, Save As, and save it as leg bottom. Now we're going to open up the leg base. I'm just going to make sure that it was in the same directory over here, and we can do the same, but with cutting the slot on the bottom side. So let's select this point, this line, and this line. Create sketch in plane. Another rectangle. Let's create a point. Snap that point to the line. Let's make that point in the middle. Let's snap that point here. Let's give it a thickness with making this equal. Let's add a construction line. Let's make it vertical. Let's snap this point to this line. And let's make this new construction line the same length as this, like so. And let's check, yeah, that's okay. So we can go to our 3D mode, select the new group extruding active sketch option, select the difference option in the property browser, and enter a reasonable extra length. So from that point, like so, and finally save it. Oh yeah, I didn't want to save over, but we just did. So I'm gonna save it as like top. Yeah, so here we go. And next we create a new file because we need to create the top part of it. And yeah, you guessed it's this round part. So we can snap it to the center just by selecting the center point of both our coordinate axis and the circle. So point. And we can give it a diameter. So the diameter is 300, like so. And we need to extrude it. And here I'm going to enter the distance as 10 again. So 10 millimeters, that's going to be our thickness. So if you always need to also measure your material. So it might be 9.8. So whenever so in the CNC week, we're going to talk more about that. And also even in the computer controlled cutting week, we can talk more about that. And next is we need to create some pockets or some cuts into it. Okay, so a point and a normal. Okay, so let's select the point and this normal over here. So these blue lines pointing somewhere are normals. So these are like but yeah, so you select the point and the normal and like this. So now we have sketching plane. And what we need to do, we're just gonna again draw a rectangle. We're gonna add point that is gonna be in the center of this. And make it in the middle of here. And now we're gonna make these 2 points horizontal. So that so now they are symmetrical around the center axis. Next, we need to add a dimension here. So as we remember, this is 40 millimeters, and the distance between this and this is 20. And then the length of this segment is going to be 10, like so. And I think, yeah, that's all we need. So we can go to 3D mode again, and we can cut it through by choosing the difference option over here. And I'm just gonna add distance of 10 millimeters again here. And then instead of drawing them one by one in all the other locations, we're gonna take advantage of the new group step and repeat rotating option. So, and it works as well with positive extrusions as with negative. And instead of 3 times, we want it to be repeated 4 times. And here we go. And again, it has like 1 degree of freedom. I really need to figure this out, but this looks good. So we can now save this as and call it surface. So yeah, so now we have all the individual parts in individual files. So we can create a new file and save it as assembly. And in order to proceed, we can use this new group linking assembling file. So when you click this, file dialog is going to open. Go to desktop. So demo. So let's start with the leg button. Okay, so it imported it. We imported it like this, and I'm going to choose the y-axis as the top axis. So I'm just gonna. So first, snap it to the center over here, and then go here, and constrain them to be the same orientation. And then gonna import the other part. So wait, which one was this? So this was the leg bottom. We need to import the leg top. Like so, and I'm gonna take this and that, go to constraint them to be the what? Okay, now we got it. So a little bit fiddling around. Didn't expect this really. And now the last part is we just snap these points together over here. And now we have an assembly. And lastly, we need to import also the surface, like here. Moving around. It doesn't really matter. I think it's just going to be enough with snapping these together. Probably not. Now we also need to align it somehow. So let's align this with y-axis. No, didn't work. Let's go a step back. So here are these pointing down. Let's go here. Let's make them right. So let's select the normal and then the y-axis and then constraint, same orientation. So now it's facing up. And we can select the point on the bottom over here. And the midpoint on the top over here. Go on point. So yeah, that's assembled 3D object. So from here, you can export that as a triangle mesh, for example. So as an STL file, so OBJ file, no problem, or VRML file. Yeah, so probably because it's consists of several objects, there might be some problems. So it all just dumped all the vertices in one file. So maybe a smarter way would be just to export each of the objects separately as 3D files. You can do that. So you can close and open. So demo. So let's say the leg top over here. And we can export it as triangle mesh. And now in MeshLab. MeshLab is really nice software that you can use for different purposes, for fixing 3D geometry before 3D printing, to actually making a 3D object out of any kind of 3D scanner that that can produce a point cloud. Here you go. So that's a separate object. And you can view what is the geometry, like the triangulated mesh features of it over here. There are all kinds of filters that you can apply to the object or to the point cloud later. Another thing that might be useful to you is, let's say in the laser cutting week, you want to laser cut this. So how do you do that? You will need a two-dimensional drawing. And in order to produce this two-dimensional drawing, what do you want to do? You want to choose the surface that is going to represent the outline of it. And then you can activate this face selection mode. So make sure that it's unselected over here. You can select the face. And you can go to File and Export 2D section. And you have several options of what kind of file types you can save. You can save it as a PDF file, which is totally fine. You can save it as an EPS, which is sort of an older Illustrator compatible file, or DXF. Also G-code, by the way. So you can just generate raw G-code and then run it with a CNC machine and see what happens. But PDF is relatively universal because the software that we use with the other machines, let's say with the laser cutter and with the CNC machines, supports PDF quite well. So with the laser cutter, we use Illustrator, and you can import PDF files, or actually EPS is even better. And then for the CNC, we use a software called vcarve, and it can import pretty much anything, even Illustrator files. So here PDF is fine. So let's export this as PDF. And let's open Inkscape to verify that it worked. So let's create a new document over here. And let's go to File, or Open. Let's go to File, Open. And there's this, not this, but let's Nemo leg top. Open. So all these programs, they're going to ask you for some options when they are opening PDF files, because they need to somehow change this PDF file in a way so that you can do something with it. So in Illustrator, the dialog is going to be also there. Maybe it's going to look a little bit different, but the default settings here, they are totally fine. Okay, and here you go. What is really great about SolveSpace and this export of drawings is that it actually creates closed shapes. So sometimes with Fusion 360 and with FreeCAD, you end up with having these lines separated, and it's a huge pain when you are trying to laser cut lines that are separated. So SolveSpace generates really nice drawings, closed shapes, no problem at all, as you see. And then, well, that makes the whole cutting process much easier if you have drawings that are actually closed. So you see it can create these. But for now, I like this tool because it's really easy to get started. Basically, you can use this software to generate designs for your 3D printing and for laser cutting, for CNC milling, for all of the things that you're going to do in this course. Maybe, except electronics design, but you'll be able to import electronics design 3D files in here in order to validate whether your enclosure or your project actually fits together with that.